Good afternoon, one and all. Welcome to the 12th edition of the ISTD-IIMT Upskilling Lecture Series on Deep Learning and its application in medical image processing. I am Alok Arun, Professor in Charge, Training and Placement, IIMT Bhubaneswar, is the host for today's session. The ISTD-IIMT Upskilling Series, led by the ISTD Bhubaneswar chapter, in collaboration with IIMT Bhubaneswar, aims to equip individuals with essential corporate skills covering areas such as communication, leadership, technology, teamwork, and problem solving. The program includes workshops, seminars, and practical exercises. It prepares participants to navigate the corporate world effectively, fostering the adaptability and confidence for success in various roles and situations. So moving on to today's schedule, we have with us Professor Dr. Pramod Kumar Pusti sir, Principal IIMT Bhubaneswar, who will be speaking a brief about our institute. The welcome address and the introductory remark will be given by Dr. Paresh Chandra Mahathi sir, Director at Stalin Sigma Professional Private Limited and Secretary of ISTD Bhubaneswar chapter. Our eminent speaker, Dr. Rahul Jain, will be giving his talk on deep learning and its application in medical image processing. And after that, we'll be having a feedback and interaction session at the end. So now I will be introducing the list of eminent speakers, those who have given in these last 11 editions their talk and have enhanced the skills of our students and have been continuously working for the development of the students. In the first edition, we had Dr. Paresh Chandra Mahathi sir himself delivering the first edition. The second edition was given by Dr. Purnima Bakchi madam and Mr. Mohit Jain. Third edition was given by Dr. Megha Sharma and Mr. Kaushik Anand. Fourth edition was given by Mr. Manas Pratim Goswami and Ms. Meena Naik madam. Fifth edition was delivered by Mr. Siddharth Mahanti. The sixth edition was given by Mr. Siddharth Sahu. Seventh edition was covered by Mr. Arvind Das. Eighth edition was given by Mr. Jasovan Narayan Singlal. Ninth edition was given by Mr. Subhranshu Sekhar Samanta. The 10th edition was given by Mr. Avinash Kupni. And the last edition, the 11th edition, was delivered by Dr. Mosmi Pandya. Now, let me introduce to you Dr. Paresh Chandra Mahathi sir, Director at Talent Sigma Professional Private Limited and Secretary at ISTD Bhubaneswar chapter. Dr. Paresh Chandra Mahathi sir was a banker and for 25 years and has worked in various capacities in India and abroad. Currently, he is the Secretary of the ISTD Bhubaneswar chapter. He was a corporate trainer for 17 years, having expertise in management, banking, and finance. He is a motivational speaker and has been conducting career counseling sessions for students of various management and technical colleges. As a guest faculty, he has been taking sessions on OB, management, and banking for various management colleges and guides students, job seekers to participate in GD and how to face interview board. He is an author of several books and has published various articles in reputed magazines in India and abroad. He is a YouTuber and gives radio talks for improving personality of rural students and youth in urban slums. He is also the editor of the e-magazine, The Mirror, which has been published by the ISTD Bhubaneswar chapter. Now, let me introduce to you our today's speaker, Dr. Rahul Jain, who is doing his postdoctoral research at Ritsukumigan University, Kusatsu, Japan. Dr. Rahul Jain received his BCA degree from Dr. H.S. Gaur, Central University, Sagar, India, and his MCA degree from RGVP University, Bhopal, India. He earned his PhD from Ritsumikan University, Kusatsu, Japan in 2022. During his doctoral studies, he worked as an intern at AI startup Iwaki, Japan. He is currently a postdoctoral researcher at Ritsumikan University, Kusatsu, Japan. His research interests include computer vision, machine learning, object detection, and image processing. Now, I would like to call Dr. Pramod Kumar Pusti sir to give a brief introduction about our institute. Sir, please.
Jai Jagannath. A very good afternoon to one and all present here. A hearty welcome to all our distinguished speakers and participants as we embark on another captivating journey in the ISTD and IIMT lecture series. InterScience Institute of Management and Technology Bhubaneswar was established in the year 2007 with an objective of teaching science of management in addition to the practice of management. The name itself explains about the scientific study of management, and further to mention that it is inscribed in our institute logo. We are a UNESCO Unitarian Institute of a UNESCO Chair, Professor of Economic Systems and Human Rights, Professor Francisco Vigliarolo, National University of La Plata. Let me now explain what we mean by teaching science of management. During these 15 years of excellence, we have organized, facilitated more than 100 symposium, seminar, workshops, national and international in various niche areas of management and technology. Since our inception, we at IIMT have edited and published more than 100 volumes in the area of management and technology from reputed publishing houses like IEEE, ACM, Springer, Elsevier, iOS, SPY, Fluor Academic, MDPI, Hindawi, or IndoScience, etc. All these books are available for purchase from Google or Amazon. All our faculty members are engaged in these activities. Each year, we invite and host professors from abroad for workshops and seminars. I am tempted to say that last year, Professor Jesus Garcia from Universidad Complutense de Madrid and Professor Vijayan Sukumaran from Auckland University School of Business visited our campus. During the month of April 2023, Professor Vipul Jain was here from Victoria University, Wellington, for a month on a research exchange program. We publish management books through our own in-house publication, that is IIMT Lecture Notes on Management, where we publish the essential books like Self-Management, Career Guidance, and Emerging Fields of Management. We have started one channel, namely IIMT Open House in YouTube. The purpose is to educate students and parents at large on various subjects and disciplines through talks and interviews. By now, we have more than 100 episodes available at our YouTube channel, namely @IIMT Open House. We have taken interviews with professors, professionals, entrepreneurs, and policymakers. We have created a platform known as InterScience Research Network, consisting of professionals and researchers. It is available at www.interscience.ac.in, through which we organize various programs inside and outside India. We do arrange workshops and seminars at various universities. IIMT, in collaboration with ISTD, had successfully organized the first edition of an annual event on disruptive human resource management, people, technology, and strategy at IIMT campus, Bhubaneswar, during 13th and 14th January 2024, under the guidance of Dr. Paresh Chandra Mahanti, Director at Talent Sigma Professional Private Limited and Secretary, ISTD Bhubaneswar Chapter, and Dr. Prabodh Kumar Mahanti, Chairperson, ISTD Bhubaneswar Chapter, and Senior Director, HR and Skill, KIT University. We are planning to organize the second edition of Disruptive Human Resource Management, People, Technology, and Strategy during 11th and 12th January 2025. In order to increase the efficiency of the millennial generation towards placement, IIMT is launching a book on corporate readiness during the last week of November 2024. The book will be edited by the esteemed editors, Professor Mukesh Chaturvedi, Master of Management Studies, BITS Pilani, Adjunct Professor, Jaipuria Institute of Management, India, Dr. Chandrai Mukherjee, Assistant Professor, IIM, Visakhapatnam, India, and Professor Dr. Srikant Patnaik, Director and Professor, IIMT, Bhubaneswar. We do hereby request all our esteemed speakers and participants to contribute a chapter for the book on corporate readiness at publication@interscience.ac.in. Thank you all. Now I would request Mr. Alok Arun to carry on with the session.
Thank you, sir. Thank you so much. Now I would request our chairman, Dr. Shrikant Patnaik sir, to kindly speak few lines regarding our. Sir, please.
Good afternoon to all of you.
Good afternoon,
Good
sir.
evening to Dr. Rahul Jain.
Good
In
evening,
fact, you must have heard about our endeavor, IIMT, Inter-Science Institute of Management and Technology. We are existing from 2007 and we are proceeding. And this year, we are very happy to say that we are entering into engineering. So we are also applying computer science and engineering, artificial intelligence, and machine learning, then cyber security, then data science, in addition to the core branch like civil, electrical, and mechanical. So we'll be happy to collaborate with you. So that is the purpose. Since the last 11 episodes, we are choosing professionals from management discipline. But I told Alok Arun to this time you choose professors and academicians and experts from engineering and computer science background, because we are entering into very shortly, by July we will be there. So I'll be very happy to welcome to this family of InterScience family. In addition, because we have 3 verticals, in one vertical, we do networking session, conferences, symposium, and other tutorials. Today also another symposium is going on, probably 1 hour before that symposium is over. And the name of the symposium was Social, Ethical, and Legal Aspect of Generative AI. And in the afternoon, you are speaking to us. So this is one vertical. The second vertical is our engineering and management. Previously, it was only management, and maybe if God's grace, God's permit, from July, we will be, say, opening engineering. So engineering and technology. So we will say satisfy our name. We'll justify our name as IIMT, Management and Technology. So management word was first, so we opened in 2007. Technology was added later, so we are entering in 2025. So Dr. Jain, whenever you are visiting India, please make a plan to visit our institute to Bhubaneswar. And I know you are a prolific researcher, and at this young age also you have edited volume and say written paper. So we can collaborate. Our teacher will be joining within, say, 6 months' time. And here also few of our members who are also engineers, and they will be in touch with you. Whatever work you are doing, so you have edited 1 or 2 volume, written 1 or 2 book, but we have done 100, more than 100 volumes from different publishing house. So you will find a pleasure working with this group. And and we have a very strong network over the world. More than 100 mentors are there from different disciplines, from different country, and from different age group, different races. So it is truly, we are an international body, and gradually one after another, people are joining with us, people are knowing us, people are say appreciating our work. Here also I am happy to say that we are running a lecture series on human rights and economic system. And this is driven by one of our UNESCO professor, Professor Francesco Vigliarolo from Argentina. And after running for a couple of, probably that is also 1 year, we are crossing 1 year, 11th or 12th edition we have completed. And by now people are knowing, and the company like Aditya Birla Group, they have invited me to they will deliver a couple of lecture on human rights. So I am going to deliver to Aditya Birla Group employees on say 17th and 18th. So this way, whenever you are, and for your information, whatever you will talk today, it will be tomorrow or day after tomorrow, it will be uploaded to our YouTube channel. So people will be say seeing you, people will be say getting your information, and if they are appreciating, they will be calling to different other forums also. So that platform also we are giving. So with this, I thank the very dedicated team since 1 year. Saturday, second Saturday of each month, we are conducting, and I am confident now it will not stop. It will continue further. Thank you.
Thank you.
Thank you, sir. Thank you so much. Now I'd like to invite to the forum Dr. Paresh Chandra Mahathi, sir, to kindly provide his introductory remark regarding the session. Sir, please.
Thank you, Alok, Dr. Shrikant Patnaik, Dr. Rahul Jain, Dr. Pramod Kumar Prushtri from IIMT, and our Alok, who is the coordinator. And previously, this was coordinated by Professor Soma Mitra, who is present also. To give a brief background to Dr. Rahul Jain, that Indian Society for Training and Development, or ISTD, is perhaps the only organization on training and development in India that provides a certificate which is accepted throughout the country to the trainers. And it was established in 1970. So far, there are 50 chapters in India. And one of the most prominent chapter is Bhubaneswar chapter, having around 350 HR experts who are the members. Dr. Shrikant Patnaik, the founder of this IIMT, is also a central committee member of our chapter. 1 year before, in 2023 December, in our managing committee meeting, he gave this idea that we are doing so much training for the job holders, the professionals, but why not for the job seekers, those who are trying to establish themselves in the professional world. So this program started then, and usually in our sort of organization, nothing lasts long. After some months or something, it collapses. Then another new things comes up. But fortunately, two things are running by our chapter continuously. One is this one, we fixed a target that we will have 12 episodes, and calling the prominent speakers who will be inspiring the youngsters or guiding them to be professionals. And this one is today is the 12th chapter, 12th talk. And it is one of the most successful program ISTD has done in collaboration with IIMT. We are collaborating several organizations, but this one is the most lasting because of the leadership of Dr. Patnaik and his team. Then another thing which is lasting, last 4 years continuously it is happening with ISTD, is we are publishing a quarterly e-magazine on HRD. And that one also, this December, we will be completing 4 years. 4 years means 16 issues that will be complete, and I hope that it will continue. These are the two great things. And I have already told you about ISTD and our endeavor, and we are fortunate today to get you, Dr. Rahul. That is also because of the connectivity of Dr. Patnaik, and usually because the offices are running, the attendance become very small. Okay, but you don't get discouraged. You continue. You thinking like I'm talking to 100 people, because thousands of people will observe it later. So with full of your enthusiasm, you make the presentation. Then after some questions, definitely they will put, and we will have a live discussion. Thank you very much. And now, Alok, you take care.
Thank you, sir. Thank you so much. Now I'd like to call upon the forum Dr. Rahul Jain, who will be presenting his talk on deep learning and its application in medical image processing. Sir, please, the forum is yours. You can share your screen.
Thank you very much, professors and everyone, to invite me for this talk. I am honored to join our team, and I will collaborate in future. So mainly I made my slides according to my research. So I will try to explain in a simple way what we are doing here.
Sir, kindly make it a full screen. Okay, okay, done. Thank you.
Yeah. So is it visible? My slides, can you see?
Yes, sir, it's visible. It's visible.
Okay. So recently, AI is everywhere. We are implementing AI-based techniques from real-world images to medical images and different domains. And basically, recently we are using deep learning-based methods, which is we can say this is new AI techniques. These are the state-of-the-art techniques and has achieved great success for in the field of automation. So as you already know, my name is Rahul Jain, and I completed my undergraduate and master's degree from India, BCA and MCA. Then I came in Japan in 2019 to pursue my PhD degree at Risumeda University. I will introduce my university and my lab after my presentation. So AI, we can implement AI for different tasks. So mainly my research is based on the computer vision or image processing. It mainly includes classification, detection, and segmentation tasks. So for the classification, we can classify any given image as like what the object is present in the image. For example, here there is a horse and a human. So we can classify the image, what is the object is there. Second task, we can consider detection. So in the detection, we can classify the part or the any contour of the image, and then we can also draw a bounding box around it. And while classifying the bounding box, we can also precisely locate its position within the image. So it is, we can refer as an image detection task or object detection task. Next task is the image segmentation. It can be considered pixel-wise classification. So each image has several pixels. So each pixel can be classified, and we can group those pixels into a group, and we can get its mask. So it is called the generated segmentation mask. So these three tasks mainly are the main tasks in the computer vision field. So we can use traditional machine learning based languages or additional deep learning based techniques to perform this task. So before the evaluation of the deep learning based method, we used to use some machine learning based techniques. So these are basically based on the low level or mid level features. So these low level or mid level features, we can we can consider them as a statistical based features. Based on that, we can define the features or attributes of the given image, and then we can further perform any task specific operations. So task specific operations we can consider like classification or object detection or image segmentation. And recently we have deep learning based network where we can extract high level features automatically using the convolutional neural network. Then we can achieve the task specific. We can perform any task specific operation like classification, detection, or segmentation. So these are end-to-end network based on the deep learning, and the fundamental of the deep learning is the CNN, convolutional neural networks. So the basic idea of the deep learning or AI is here. We have a model. We say a deep learning model. It has some layers. These are layers are CNN layers, and it also includes some other layers or operations. So the model is given some examples, and it has its corresponding output. We say it ground truth, and based on the predicted output and the actual output, we can calculate some kind of difference between the both. So it is basically calculated by some loss functions, and that loss function is gone through some optimization process, which are used to update the weights of the model. So it is called model updation process. So here we learn from the given samples. So these samples basically are image. If we consider a visual task, so these images have some labels, corresponding labels. So based on the input and based on the output, using the ground truth, we can learn or we can train the model to perform our task, which we want to achieve from it. I will introduce classification, segmentation, detection tasks. So here, for the classification, we have a given image. That given image, we want to assign a single label. For example, based on its object. So we provide the image for the deep learning frameworks. These are the CNN layers, and these CNN layers automatically extract high-level features from the given image. Then we have some other component of the deep learning network. Then we can get the final output. So the final output is compared with our ground truth. Ground truth are our real labels. So based on the predicted labels and the real labels, we can calculate the disparity or the difference between these both generated and the real output, the real ground truth. Based on that, we can optimize the network, and we can have a learned model for our specific task. And these are some representations, like how the CNN layers process any given image and how it generate high level features, and then how it encapsulate the information from any image, and then it turns it to a single label. So this is the task of classification. In the image segmentation, we classify each pixel value. So for example, this is binary classification. So we have a CT lever image. We can classify the lever pixels. So this is the lever mask, and it has some tumors. So we can also classify the tumors. So it has the tumor mask. So this is the segmentation mask for the given lever image. Here is the object detection framework. So it also includes several components. It has a detection head which operates over the extracted features. So during training, we need to provide the image, its bounding box and label. And during the inference, when we implement the model, we can automatically detect the object. So here the example case is the tumor. To train these deep learning based models, we need a lot of training data. So we need to get the manually annotations. So my research is based on the techniques, how we can reduce the dependency of the manual annotation to train this model. So my doctoral research topic was developing robust and domain invariant detection models to address the domain shift problem. So I used both real world images, and I used low detection task and lever lesion detection task to address the domain shift problem. So these are when I started my PhD, so I found two major challenges. One is the limited training data problem, because deep learning based models require huge amount of training data. So to learn the model, we need to provide samples, and these samples or annotations are not easy to get for any specific task. So one is the lack of the training data issue. Second is the domain shift problem. So if we have any other any data set, and if we want to employ the trend model using that data set to any other specific kind of data set, so we found the accuracy goes down. It underperformed due to the domain shift problem. So I will introduce these problems in the next slides. So first, to train the deep learning based model, we need to get the object level annotations. So for the detection task, we have object labels. We need to draw bounding box manually, and we need to define the class of the bounding box, category of the bounding box. Similarly, we need to annotate segmentation mask. For segmentation task. When it comes to the medical images, so it is more difficult because these masks should be annotated by the radiologist. So it is very difficult to to find or hire radiologist to get the huge amount of training data for the AI models. So we can say it is time-consuming, labor expensive, and costly task, and it is very difficult to get suitable person expert of their field or domain. Another problem is the domain shift problem. So different view, when we capture an image from different viewpoint of the cameras, so different data set may have different characteristics, view, different size, object sizes, or image quality. These all factors affect the performance of the model. So we found a domain shift problem when we use one kind of data set and we use the trend model for the another data set. Specifically, if we want to generate automatic segment or annotations, for example, synthetic images. So these models are not applicable for the real world images due to their performance. So domain shift problems may arise between different data from different centers or multi-phase data sets. So I will talk about multi-phase data set. What is a multi-phase CT or MRI data set? So for the conventional approach, we need to retrain the model using the specific data set. So it requires again a lot of annotation and a lot of time-consuming task there as the annotation is. So we need to use some approaches like domain adaptation to align the weights of the network in a common shared space, so we can get a robust model. So we have some domain adaptation methods for this task. So these are some visualization of the features extracted from the images. So we can see without the domain adaptation, the features are far from each other. But if we use some domain adaptation based techniques, we can generate the features in a common shared space. So that's why these domain adaptation based methods are important for deep learning based models. Basically, domain adaptation based methods, to employ the domain adaptation based methods, we can include some target images. So here, target images are unlabeled without annotation target domain images. And we learn basically more from the labeled source images, but we can incorporate these unlabeled target images to align the weights. So here we can use some kind of techniques to mitigate the domain gap between these two data set. So I work on in the field of domain adaptation to reduce the domain gap between different types of images, synthetic to real world images, or images from different centers and images from different city faces. So I employ different kinds of strategies, and based on that, I try to improve the robustness and accuracy and performance of the model. And based on these schemes, I also published some papers. These are the multifaceted images. So in the medical imaging, we may have data from different centers, and each center, data from each center may represent different kind of characteristics due to the different regions. For example, if we have multi-phase data, so the multi-phase data includes 4 or 5 types of data: NC, ART, PV, or delete phase. So these are the CT image phases which are taken after giving the contrast enhanced agent, which is a agent or injection which we given for the patient to emphasize the tissues information and to get the abnormality of the tissues or tumor region more clearly. So these different phases are considered by the doctor to make the judgment about the tumor in the liver part, also for the other body organs. So to perform the decision or to learn the AI model, doctor usually need to do separate annotations for each phase. So it is a kind of burden for them. And also if we have data from different centers, so it also exhibit different kind of characteristics. So we need to get the AI models which can be aligned for different type of data sets. So this is the main problem when we use medical imaging for AI for medical imaging. So this is the how we can learn the model. So here we have object detection loss. So it is, we can consider the bounding box, position, and its category. And based on that, we can get one loss. Loss here we can say some kind of direction to update the model's weight to learn effectively recognize the tumors from the CT images or the object from the given image. So it is, we can say, our guiding signal. So we have some functions, loss functions, and we have some optimization techniques where we use gradient descent kind of optimizers to update the model's weight. Model's weight, like CNN layers, we have some weights assigned for each layer, so we can update the model for our specific task. When we want to use domain adaptation for the detection task, we can use some kind of adversarial losses or some kind of different type of domain adaptive losses. So one is the one of the common strategies is adversarial loss. So it can move the feature extraction network to learn the features to perform the detection for another for the data from another domain. So this is its function. Like we have main object detection model, we can add some other small network, and we can get some optimization signal for this network. And also we can get we can follow some strategy where we can get one kind of signal for this detection network, so that we can update the models, this model where it can move the this discriminator network, and discriminator network can move this feature extraction network, and this we can get the robust model which is more aligned towards the target, our target feature. So the strategy is, we have source is our training data set, main training data set, and target is our test images which we don't have annotations. And using this kind of training strategy, we can update the model's weight in a way that it can perform well on both types of data sets. There are some other methods we introduce for our task, like maximum square loss added with the domain adaptive losses to further improve the model performance. Maybe I can skip this because it is technical, so I will talk about the utilization of the trend model. And we have some other feature methods like feature variations, where we can use scale divergence with loss between the extracted features. So here we can use different types of strategy, and we can check them which is better or which is well suitable for our data set. So here we have some experiment results. So if we use, this is a baseline method where we use CenterNet and DLA. So this is a detection network we can consider. If we use different kind of strategies, so we can achieve the accuracy improvement for the accuracy for different ways. Like here we use LITS is a private data set, and we use our in-house PV MPCT FFLS dataset. This is a private dataset. So when we use one data center to another data center, we found the accuracy is improving and our model is robust without any extra annotations. Similarly, we use different phases from PV to ART and PV to NC. So for all cases, we can see the accuracy is improving. That means our model is robust enough, or its performance is improving. These methods are also suitable for different phases, like within the same center, like MPCT, FFL to PV to MPCT, FL, ART. So ART and PV, two phases of these CT images. So we can also improve the accuracy for different phases. So in that case, we can just need annotation for one phase, and we can employ the model for other phases. I also use some other method like Fourier-based method, where we use its phase and amplitude component to further improve the data. So here we introduce some variation in our training data, and we can get good accuracies or better models. So these all our efforts to reduce the data annotation problem. As I told, deep learning based model requires huge amount of training data for training any model, which is good enough for employment. So our research is focused on how we can handle the data issue, how we can mitigate the lack of training data problem, how we can use the same data and we can get good results for other data sets. These are some performance accuracies when we use these kind of methods. So these are some visualization. Here we have ART faces images. These are ground truth images, and these are our method. These are the baseline model without domain adaptation. And when we use our domain adaptation method, we can our AI model can detect tumors well in various types of CT images. I did my internship in a AI company here in Japan. So they have some kind of projects related to the logo detection or brand detection. So we want to avoid the manual annotation task. So we synthesized logo images. So we just used the one-shot logo icon and we generated these kind of images. But these kind of images are not very good to train a robust or any model which can be implemented on the real-world images. So we found there is a huge domain gap between the synthetic and real-world images. These are synthetic images left side, and these are the real-world images. So I also work on for the real world or normal images. So here we introduce one entropy minimization based method for logo detection task. So our work we can employ unsupervised logo detection method by automatically generating synthesized images, logo images, and we employed logo DOM adaptation to perform the detection on the real world images. So our work is accepted by one IEEE journal, and this is also applicable for the real world. This is the detail about how we employed the entropy minimization. So we consider that entropy is related to the prediction. So if the entropy is high, then the prediction is messy. But if the entropy is low, then we can say the prediction is good. So we can avoid the noisy and we can reduce the entropy. So this is the main idea. Here some question details based on how we implemented the entropy minimization. These are some results. So our accuracy improved, the accuracy is improved, and our model can achieve state of the art results in comparison to the other methods. Recently, there are several foundation models are introduced for various tasks. For example, segment anything model, which is introduced by Facebook. So it is kind of one-shot image segmentation task where it can segment any prompt where it can conduct segmentation task based on the prompt-based method. So we also try to use these foundation models for the medical domain. These foundation models are used on a huge data set, and they have potential to use they have potential to use for the medical imaging, but we need to find good some strategies how we can fine tune the weights or how we can use these kind of models for the medical imaging. So we recently used the same model for the detection task. Here this is our strategy. Here we used one additional CNN network, or we introduced basically one efficient way of fine tuning the entire model, and we employed this model for the medical imaging, and we achieved better results. These are some results of the study where we used different studies with the same model to employ the foundation model for the detection task. I'm also engaged with other research in our labs. So these research are related to the segmentation, medical image segmentation. So recently, transformer-based network has achieved remarkable success, but they have redundant information. So we also used different graph or hypergraph-based method. This is another method where we used segment and encoder. This is also segment anything model, and here we used it for the medical image segmentation task. In this work, we used a graph convolution network for the segmentation task to reduce the redundant information and to create an efficient AI model which can achieve good results. So in that, we used medical image segmentation task, perform medical image segmentation task using segmentation model, while we introduced some GCN-based method to improve the segmentation performance. This is our another work where we extended the previous work towards hypergraph construction method, and it is recently accepted in the MIPCI conference. There are some other ongoing projects where we also classify the tumor and the lesson from the liver. So we also want to know the type of the tumor, whether it is the cyst or some other categories, like for example, SCC is the dangerous liver cancer type. So we also do classification tasks for the medical imaging, where we classify the tumors, with the type of the tumors. We also have image enhancement methods. So as I told, we need to give contrast enhancement injection for the patient. It may have some side effects for the patient. So we also trying to generate, our recent AI is also working in the field of generating images. So we can generate NC to ART or NC to PV. So NC is the non-contrast image. Here the CT is conducted using without giving any contrast enhanced injection, where we want to generate its corresponding ART or PV phase. So the ART and PV phase includes more information about the tumor. So these kind of research to enhance the image we also conducting in our lab. So this is method related to the generative adverse AI, where we get trying to generate the contrast enhanced medical imaging. In Japan also, we need to employ our AI models for the practical to show its practical applicability, because just publishing paper is not enough. So here we emphasize on the practical implementation. So during my intern training, I also realized one algorithm for counting, and here we have these scans, and if we run it on Jetson Nano, and it can lively count the number of the scans available in the video. So this kind of work also we have in our labs for practical implementation. So basically, our research is based on computer vision task, and we mainly focus on the medical imaging. So the key contribution of my research is it is effective to recognize the anomalies or tumors from the liver images, and that these methods are also applicable for the other body organ part. So these are also applicable for different medical images. It reduces the domain shift problem between different phases or different centers. So it reduces the annotation problem. And we also have robust data AI models. So we have more generalized framework. We can apply it for different types of data set. And we have also radiologists here who provided for us for the data, private data. So they also acknowledge our algorithm. It is effective. In the next, the current AI, we are trying to fuse different types of modality data. So for computer vision task, now we are going to use it. We are going to fuse it with NLP, natural language processing. So where we have some text information and image information, so we are going to fuse in a way that we can improve the framework or AI model and make it more accurate. So these are some other current work where we are working. So basically, we are now going to fuse different modalities. This is all about the research I'm engaged. And now I'm going to talk about my university and lab. So I currently am working as a postdoc researcher at Sumikon University. Our university has 3 campuses. One is in Kusatsu, Ibaraki, Osaka, and Kyoto. So now my campus, my lab, and the entire information science and engineering department has moved into the Osaka Ibaraki campus. And this is a private university in Japan, and it is considered one of the top level university among all the private university in Japan. I joined Professor Chen's lab. My supervisor, PhD supervisor, and my current head of our lab is Professor N. Chen. His lab has completed 25 years, and it primarily focuses on the medical use task. It is working. Our lab members are working on different medical imaging and other medical problems. So the lab name is the Intelligent Image Processing Lab, and he's my professor. These are some pictures of our lab where we have different machines, GPU machines, and other equipments, and they have two labs. So this is the first row showing the first lab, and this is the second lab. And something about Japan. So Japanese work culture is they work very hard, and the people are very honest, and they are dedicated, and they have huge respect for their tradition, and also respect for their hierarchical system in the organization. And if you want to come Japan, you will learn more from them, and it is good to understand some Japanese culture and Japanese language may also improve our communication among here among our colleagues and other people. So this is all about for my presentation. Thank you so much for inviting me.
Thank you, Dr. Jain. I have some general question for you.
Yes,
How is the work culture and how is the people of Japan work in the office and how they manage their work life?
First, I will talk about people. So people are very helpful, very kind, and like they are very honest as their image in our India. Like we have some kind of image towards Japanese people. Like they work very hard. So when I came here, they really work too hard. The internship company which I joined, so I saw them like working 20 like always working like 12 hours, and if the project is important and they have to meet the deadline, so they really work very hard. They do everything to put the they put every effort to complete the project within the deadline. So I learned from them like dedication and respect for the customer.
Correct, correct. So I have heard that in each university, the labs are named after their professors. So what is the name of your lab?
My lab name is Intelligent Image Processing Lab.
Okay.
In our university, usually we have a lab name based on its research research field. So, for example, we're working on image processing, so some kind of this. But the lab is headed by the professor, so his name is also there. But usually we have lab name based on the research field.
So, what is the working hour?
For lab, usually PhD students, there is no decided working hours. Like they can come and go according to their schedule. But for me, for postdoc researcher, we have to work every day 7.5 hours. So 7.5 hours. So we have flexibility to do it.
Okay.
But it is around maybe from 9 a.m. to 12 a.m. Between 9 a.m. to 12 a.m. we can start and finish accordingly.
Got it, got it. And how many classes you take per week?
This semester I don't have class, but the last semester I had class image processing, so I had only one class 1 week.
Okay.
Usually, assistant professor have assistant professors have usually 2 classes 1 week, or 3 classes in a year, something like this. So it means they have 2 classes 1 week in one semester, and 1 class 1 week in another semester, something like this.
Thank you, Dr. Jain. And I welcome you to the IIMT family. And our engineering will start from next July. And please, I have your CV and other detail. So I like to engage you as our adjunct faculty. So your name will be taken.
Yeah. It would be an honor to me. So thank you so much. I will I will try to engage and collaborate different aspects of whatever.
So whenever now my fellow colleagues are here, we usually prepare around more than 20 proposals to be submitted to different publishing houses. So I'm also all of my faculty members are also attending this program. So they will be contacting you for kind of collaboration and will be submitting proposals with your name. Thank you. Thank you. Now the floor is open to take question from Dr. Mohanty and other.
Yeah. Sir, I have one simple question also, that in India, usually the educated fraternity, they give a lot of importance to English in comparison to other Indian languages. What is the position in Japan?
They work in Japanese mostly, so specifically in the regional areas or the like metro cities like Osaka and Tokyo, you can find English culture, English language culture in the
Okay.
companies. But the other region, they mainly use Japanese. They have everything in Japanese. Their machines, their system, all things are in Japanese.
Okay. Yes. Now our Alok should have a technical question because he is a technician. Where is Alok?
Please ask.
Yes, I'm here.
What is
Uh,
your question?
Now, the thing is, I'm curious about this. Means, as we are stepping into a new domain named as generative AI.
Yes.
So how are you, sir? How are you seeing generative AI is taking over? Like yesterday, I had a discussion with our sir that there will be a difference between smart manager versus an AI manager. So what kind of a difference what kind of impact that AI will have on have on human beings, and will they be able to replace human beings, or they will be a helping tool for the human beings?
Uh, in my understanding, where like whether I came across the accuracies and the precisions like the determined by the AI. So I feel it is a great helping tool for the human in different fields, whether it is medical or automation, different kinds of automation. We cannot leave all things. We cannot on them because we need to carefully monitor the system. Even the chat GPT is there. We need to whenever we use it to generate some kind of, like, for example, if I give the text image or text annotation and I try to generate the text for the corresponding city image, I found they make a lot of mistakes. So current AI is a great helping tool for the human being, and taking over is it's not possible in near future.
Sir, so is it like a helping tool, a guiding tool, like we use computers for calculations or coding? Is this that kind of a helping tool or for the human beings?
Uh, Maybe now it is very smart. AI is very smart, so it can help more than just coding or calculation. It can also suggest some good way of like techniques how you can improve. But still, we need to drive the AI to get certain like some to get some perfect results. We still need to drive it. So it is very smart. We can do the things in a few seconds, or it can save a lot of time. But still, we need to drive it according to our need. So I will not say just it is helpful for coding or just for the calculation. It has potential to help in a like great way, but still it is we cannot like it cannot dominate or take over the human.
Okay, sir. Thank you. Now I will ask other participants to ask if they have any questions.
Yeah.
Any questions?
If there is no question, then we can conclude.
Okay, okay.
Okay. Sure, sir. Thank you, Dr. Rahul, for delivering such a wonderful talk. On behalf of the organizing committee of the ISTD-IIMT upskilling series on deep learning and its application in medical image processing, I extend my sincere gratitude to each one of you for your invaluable contribution in making today's event a resounding success. First and foremost, I'd like to express a heartfelt appreciation to Dr. Paresh Chandra Mohanty, sir, Director at Talent Sigma Professional Private Limited and Secretary of ISTD Bhubaneswar chapter, for delivering the welcome address and setting the tone for the event. Your insights have provided a strong foundation for our discussions. A heartfelt thank you to Dr. Rahul Jain for your enlightening talk on deep learning and its application in medical image processing. Your insights into the advancement in medical imaging, the role of deep learning, and its transformative potential in healthcare have provided us with valuable strategies for understanding and leveraging the technology. Your expertise has greatly enriched our perspective on the intersection of AI and medicine, bridging the gap between technology and health. We also extend our sincere appreciation to Professor Dr. Shrikant Patnaik, Director and Professor at IIMT Bhubaneswar Chapter, and National Committee member of ISTD Bhubaneswar Chapter, for gracing us with your presence and support throughout the series. Your guidance and encouragement have been instrumental in shaping the success of this initiative. Finally, a heartfelt thanks to the dedicated members of the ISTD and IIMT for their unwavering support and assistance. Your dedication ensured the smooth execution of this event. If any of the participants missed today's session, you can visit our YouTube channel, IIMT Open House, where all the sessions will be uploaded and accessible at any time. Thank you all. Thank you very much. We mark this as a ending of the first season of the ISTD and IIMT lecture series on corporate readiness. Hope next month we'll be starting with the second season of the IIMT and ISTD lecturing series after further discussion with sir and Paresh sir.
Yeah.
And thank you all. Thank you very much. Have a nice evening.
Thank you, everybody. Thank you, especially Dr. Rahul Jain,
Thank
for
you very
gracing
much
the
for inviting,
occasion.
sir. Thank you.
Thank you very much.
Dr. Rahul, when are you coming to India next?
Sir, I will let you know, sir. It is not planned now.
Okay. So whenever you are coming, please plan for a visit to Bhubaneswar. Okay.
Yes, yes,
Thank
sir.
you. Thank you.
Thank you.
All right. You may quit now.
Okay, sir. Thank you.